Alright, so this is the first video for the second half of Trig, also called Trig Ultra. Today we are going to graph all 6 of the basic trig functions. So we're going to graph sine, cosine, tangent, cosecant, secant, and cotangent. Also we're going to define and talk about period and amplitude. So I can't tell you enough, the way that you graph any function, not just any trig function, but any function, is just to know what values the function takes. Right? Over here in the upper right hand corner, right, this is a graph of something, and the only way you can know what points are on the graph is if you calculate them, and every point on the graph is something of the form f of x for any function. And the way that you know what values the trig functions take on, or you understand sort of the unit circle, right? So right here is the horrible truth. This is a table of values for sine of x. So you can see here, and this is important, normally when we graph, we use x as a variable, right? And so when I write sine x, x is an angle. Here, x is an angle, right? X is the angle, not the x value on the circle, right? So sine always eats an angle. So all of these numbers along the top up here, and all of these numbers here, all of those are angles. And so don't freak out just because we changed from theta, alpha, and beta to x. But regardless, here now we have all of the possible values of angles from 0 to pi along the tops in blue there. And then just here are all of the values of sine of those angles, right? Remember, sine goes 0, 1/2, rad 2 over 2, rad 3 over 2, 1. And then along the other side comes back 1, rad 3 over 2, rad 2 over 2, 1/2, 0. Over here, I want to make a point, and this is because I'm just finishing grading your tests. Whenever you write sine of pi over 4, you're like, oh, sine of pi over 4 is rad 2 over 2. Well, write rad 2 over 2. Don't, under any circumstances, write sine of rad 2 over 2. When you replace a sine value with its evaluation, you stop writing the word sine. So over on the left, I've calculated rad 2 over 2 and rad 3 over 2 to 2 significant places, 2 significant digits, so these will help us graph it. But these are basically the values, and you can see that as we go from 0 to pi, sine creeps up to 1, and then creeps back down to 0. The biggest jumps happen here and here. In just pi over 6, it jumps up 1/2 or jumps down 1/2. So it's going to be really steep there. And then here, it's just a jump of 0.14, which is way shorter. And this is a jump of 0.14, which is way shorter than the jumps of 1/2. So here we go. Here I've plotted all of the values. You can see again that we're starting over here at 0, and we're ending at 0, and we're going up to 1 in the center, and that the jump here in this box is much bigger than the jump in that box. And both of those boxes have the same width, and so in some sense the slopes there are much different. That the graph of sine sort of rockets out here and then comes coasting up to 1. So you just take every possible value, for example here, if you want to know what happens at this point, right, for 3 pi over 4, all you do is you plug in 3 pi over 4 to sine, and that gives you rad 2 over 2. And so this point here is 3 pi over 4, comma, rad 2 over 2. Right? And that's because sine of 3 pi over 4 and rad 2 over 2 are the same thing. Okay, so we've graphed sum of sine. Obviously, sine can take any value. It can take negatives, it can take positives, it can take everything. So we need to figure out how to graph the rest of it. And here's where the laziness of mathematicians comes into play, because we want to be as lazy as humanly possible. We've done some work. Let's see what we can get away with doing less of. Well, if you calculate sine of x plus pi, it's the same as negative sine of x. So we just calculated all the values from 0 to pi. So if we want to calculate the values from pi to 2 pi, they're just going to be the opposite of the values from 0 to pi. And so you can see what we did here, right, is I took this graph here, and I just, well, here, let me draw it again. If I were to take this, this graph up top and drop it under the x-axis, you get, right, the rest of the graph of sine of x. So all it is it's one hump followed by one valley, right? And so that's how we get the rest of the graph. Now, we're obviously, again, not totally done, because sine can take on values bigger than 2 pi. We can plug in values bigger than 2 pi. We can plug in values smaller than 0. And so here's a couple of more super useful facts. One is that anytime you add 2 pi or subtract 2 pi from one of our two basic trig values, sine and cosine, you get exactly the same thing. So if I was to do sine of, say, pi over 6 and sine of 2 pi plus pi over 6, they're the same, right? And so what this means, and this is super important terminology, it means that sine repeats every 2 pi, and the fancy word for repeating is the period. Sine and cosine and all of these functions are called periodic. It's because you only need to know a little bit, and then the rest of the graph is just that copied over and over again exactly. And so the period of sine x is 2 pi. And so if we go here, we see that from 0 to 2 pi we get a graph, and that the rest of the graph is just, imagine having the copy function on your computer. You just copy that picture, the blue and purple lines, you copy them, and then move them over 2 pi and put them back down again, and you copy them and move them left 2 pi and put them down again. You just keep doing that over and over again. Also, here's the other word, amplitude. The amplitude of sine and cosine is half of the total area they're able to cover. And so you can see here, sine goes as big as 1 and as little as -1. And so that's 2. And so this distance here, which is 1, is called the amplitude. And so the amplitude of sine of x is 1. Okay, so now to graph cosine of x. Cosine is sine of x plus pi over 2. And if you remember, when we try to graph sine of x plus pi over 2, this is our c value in AF of bx plus c plus d, which means that this graph, the graph of sine of x plus pi over 2, just slides left by pi over 2 to give us the graph of cosine. And so you can see here, the green graph is the graph of sine that we had over here. And if we just take that graph and slide it left by pi over 2, right, and this distance is pi over 2. If we slide it left by pi over 2, we actually get the graph of cosine. There you can see that cosine of 0 equals 1, right? And here we have cosine of pi over 2 equals 0, and so on, right? And so the graph in gold is the graph of cosine. So what else can we do? Well, the graph of tangent, this is definitely more complicated, right? Tangent is sine over cosine. So if we look back over here, to figure out tangent for any particular value, first you draw a vertical line where you want to figure it out. So let's say here's a possible vertical line, here's another possible vertical line, right? And so what you would do in order to figure it out, you would take the value of sine, which is in green, and the value of cosine, and you would try to divide them. Here you would take the value of sine and the value of cosine, and you would try to divide them. And so whatever you got, in this case here, you'd get 1 over 0, which is undefined. And here in this case, you would get negative rad 2 over 2 over negative rad 2 over 2, and that's 1. So you'd go through and you'd start calculating all these values, but the short story is that every time cosine is 0, right, both of these values, we're going to have an asymptote because you can't divide by 0. And so here, right, there's your pi over 2, which is where cosine is 0. And so we have an asymptote. And so if you go and you check all the values and you plug them in, this winds up giving you a graph of tangent of x. What else can I say? The tangent of x plus pi is the same as the tangent of x, and you can check that using the sum and difference formulas for sine and cosine. And the most important thing is that means every time we go pi to the right, we get the same thing. That means that tangent has period pi. Now graphing cotangent, cotangent's cosine over sine, so we could do the same thing, divide in the other direction. But you can check that cotangent of x is the same thing as negative tan of x plus 2. Now if you just look at tan of x plus 2, right, this bit here, that would be the graph of tangent shifted to the left by pi over 2, and then the negative bit out front here just flips it over the x-axis. And so look really briefly, there's tangent, right? It goes up and to the right every pi, and the asymptotes start at pi over 2. So here instead, the asymptotes start at 0, and instead of going up and to the right, so if I was to take one of the lines for tangent, one of the lines for tangent looks like that. And so if we flip it and then move it to the left, you get the graph for cotangent here in red. And you can see I've marked where sine is 0, right? Cotangent's cosine over sine. So every time sine is 0, we get an asymptote. That's at 0, pi, and 2 pi, and so on. And cotangent is 0 whenever cosine is 0, which is whenever you're at negative pi over 2, 3 pi over 2, and so on. So here's a graph of cotangent. Lastly, cosecant and secant. So the way you graph cosecant and secant is you graph sine and cosine, and you imagine taking whatever value, right? So you pick a value here, right? This is x sine of x, and the way you get up here is by x 1 over sine of x. And so you take whatever the sine value is and divide it into 1. Well, since all of our sine values are small, right? This is small. Since all of our sine values are small, when we try to divide them into 1, we always get bigger values, which is why you can see cosecant is always above sine. The only time it touches is every time sine is 1, and that's because 1 divided by 1 is 1. And then down here it touches because 1 divided by -1 is -1. And so the graphs touch whenever sine is 1 or -1, but otherwise the graphs go off towards infinity, having asymptotes whenever sine is 0. It still has a period of 2 pi. Here we can see, right, a total of 2 pi. We start again every 2 pi, and the graph of secant is just 1 over cosine of x, and so you do exactly the same thing. You graph cosine first, and then you realize that for any value x cosine x, that this is just x 1 over cosine x, right? And that's your secant. And so that's really it. Here are all of the graphs, one by one. What I want you to do is I want you to practice thinking about these graphs. We're going to do something more complicated with them in a little bit, but I want you to be familiar with them sort of from a basic standpoint. So go ahead and look at the homework, and then I will see you in class. All right.